All right, chapter 2, number 13 says, explain the relationship between the variance and the standard deviation. Can either of these measures be negative? Explain. Oh, okay. So do you remember what they are?
Other than what I have written down now, standard deviation is the square root of variance.
That is true. The standard deviation is just the square root of variance. Variance is denoted by s squared. I'm showing one version. I'm showing the sample variance. We would have been using another symbol. But standard deviation is just the square root of variance. If you want to write it the other way, and you're talking about the population variance, then that's called the population variance, sigma squared. And if you do the square root of that, this is called the standard deviation. That is a whole bunch of pushing around symbols, right? Not really the meaning. So let's go back to their meaning. Both of them, they measure spread. So they measure spread, or in other words, variation of the data. And they measure in this particular way, and I'm just going to look at the standard deviation because we know that the difference between the two is if I get the standard deviation, I just have to square that to get the other one. It's like saying, here's a bunch of data. And I might have some here, and a couple here, and a couple here. I'm actually demonstrating with a kind of fake dot plot. Did you do a couple of these?
No.
Okay. There's more data clustered over here, right?
Right.
Than there is over here.
Right.
So the data points that are further away from the rest of the data, they're called outliers. I'm not exactly identifying this as an outlier, but that's what it'd be if it's really far away from the rest of the data. It's an outlier. And they are going to pull apart, they're going to stretch apart the set, give it more spread. They'll also affect the mean. So I'm going to try to figure out the mean, and the mean is you add all the numbers, you divide by how many there are. I'm going to say that the mean ends up like right, I don't know, here. And I'll put a little flag. And the reason why the mean isn't just right in the middle of this cluster is because you got some stuff over here that's pulling it away. The standard deviation is essentially the average distance all the points are away from the mean. So, since it's an average, it's going to be measured in the same units as the original mean and as the data. So if these are all centimeters, then the standard deviation is going to be a centimeter measure. If these are all degrees, then the standard deviation is going to be a degree measure. So you got to kind of think about that, because typically we're taking, or our earlier problems are taking like students' ages or students' heights, and those are all positive measures. But could you have a bunch of degrees like over on the East Coast right now where they're all negative? Sure, they could all be negative. Some could be a little warmer, maybe -3 degrees, and then some could be really cold, like -25 degrees. But if they are all negative, then your mean is going to be a negative number, right?
Right.
And your measure, which would also be degrees, your units, will still be, could it possibly be negative? That's the real question.
Could it possibly what?
Be negative.